In this question, we want to take this object and rotate it about x-axis and apply the shell method. So shell method, rotation about x-axis. Very good. So how do you visualize this? First of all, you have y equals to x is equal to 0. Then another thing is x plus y equals to 2. What's the intersection between these? So if you basically substitute this guy here, you get 2x equals to 2, or x is equal to 1. So for now, we know that x is bounded between 0 and 1, and you can use this to find the boundary for your y. When x is equal to 0, your y is 0. When x is equal to 1, your y is 1. So when x is 0, y is 0. When x is equal to 1, y is equal to 1. So you have the boundary for your y, which is bounded between 0 and 1. Let's take a look at the graph. X equals to y. This is just an increasing line. So y is equal to x. The other guy is x equal to 0, which is your y-axis. And the other guy is y equals to 2 minus x. So when x is equal to 2, it crosses x-axis. When x is equal to 1, it hits this line. And when x is equal to 0, you're just right here. Okay, perfect. I'm going to just graph this line segment. We don't need the rest of it. So we are basically taking this object and rotating it about x-axis. So on top here you have, but remember that here, since we're using shell method and it's rotated about x-axis, so you need to write everything in terms of y. So now that you feel more comfortable about this guy, this line here is x equals to y, and on top your x is equal to 2 minus y. So you can easily find the height just right here. Perfect. Let us just visualize this part, graph this guy, and rotate it about x-axis. I'm going to just take the rest of these. And for the sake of symmetry, I'm not worried about the rest of the things here. And let us use some dotted lines to show that here we have a 3D object. So a typical shell, cylindrical shell, is going to behave like this. Here you have the base of the shell, and then this guy is moving away from this, and then if you take another shell down here to this. So from your x values, this is your maximum x value, then it goes down to this x value, which is equal to y. So basically, you can think about it this way and start setting up your integral. So here you have your shell, for example, this shell, and then you have another shell. Or you can basically think about it this way. You find the larger volume, you find the smaller volume, and then find the difference between them, and then you have the volume of the object. So let us set it up. So I'm going to erase this. The volume is equal to the definite integral of the base, as you remember, is located on y-axis. So it is dependent on y. R is equal to y down here. Don't have other colors. Maybe this guy. Okay. R is equal to y. So the circumference is 2 pi y. It doesn't matter if you use the larger volume or the smaller volume, both of them, the circumference of the cylinder depends on y. So far you have 2 pi times y. And then for the height, again, you can find the larger volume using 2 minus y, then find the smaller volume using y. So this is 2 minus y minus 0 minus y minus 0. You have a larger volume, and then you have a smaller volume, or you can think about it this way. You can set them up in one integral as you have this height, which is 2 minus y, and then do the calculation for dy, or you can combine them together, minus the second one, which is just y, and then dy. So our focus is on this graph first, then we move on to the second graph here. Maybe you can use the same color, so to avoid any confusion, 2 pi y, which is basically the circumference, and then you have 2 pi y, 2 minus y, and minus y, and then you take the integral with respect to y. If it makes it easier for you this way, you can set it up this way, or you can say that, hey, I'm finding the volume of the definite integral of 2y, 2 pi y, 2 minus y, minus 0 dy, minus the smaller volume, which is the definite integral of 2 pi y, y dy. Either is fine. Very good. So let me just erase the second one here and calculate this integral for you. And remember that your y is bounded between 0 and 1. 0 and 1. So the volume is the integral 0 to 1, 2 pi y, 2 minus 2y dy, which in turn is equal to the volume of 2 pi, distribute this y into parentheses, simplify, you get 2y minus 2y squared dy. So the volume is equal to 2 pi, and here you have y squared minus 2/3 y cubed, 0 to 1, which in turn is 2 pi times 1 minus 2/3. So volume is equal to, here you have 2 pi divided by 3